So today we're going to be talking about exponential growth and exponential decay. And so guys, exponential growth, we've talked about this a little bit already, is a function in the form of f of x equals a times b to the x, in which b is greater than 1. So if this b value right here is greater than 1, then it looks like growth. So I'm going to just draw a little sketch of what growth looks like. Do y'all feel pretty good about that? Yes, no, maybe so? Cool. We also said that it can look where the negative growth is where it can go down. But we're going to be dealing with mostly real-world situations today. So you'll kind of see this. So guys, our exponential growth looks like this, or our exponential growth looks like that. It either goes up rapidly or down rapidly. Okay? Exponential decay is in the same exact form. But now, guys, our b is between that 0 and 1. So you notice my b is not negative. It can't be negative, but it's between that 0 and 1. So guys, like I said before, exponential decay is where it starts high and then it kind of flattens out into like a beep line. All right, so it kind of looks like this, or it is going to look like that. So your exponential decay flattens out to a flat line, or flattens out to a flat line there. You guys feel pretty good about that? Yes, no, maybe so? All right, guys. So looking at this, so the b is your growth or decay factor. And what we are going to do is we are going to determine the percentage increase or decrease, okay? Because a lot of times when we're talking about interest or when we're talking about other things, hey, guys, I need y'all to open up. We're on page 4, okay? Let's open up our notes. We're on page 4. Emerson, where's your notes copy, sir? What? You need your notes out. Okay. So here we are. We're on page 4. So guys, we look at this. We say y is equal to 15 times 0.98 to the x power. So Tessa, is this considered growth or decay? Okay. Why would it be growth? What is giving you the thing? What's making you look at it and think growth? Okay, the positive. Okay, so it is a positive number, but up here, guys, the b value is always going to be positive, so positive doesn't control the growth or decay. So if my b value is greater than 1, it's growth. If it's less than 1, it's decay. So Emery, is this going to be growth or is this going to be decay? It is decay because this 0.98, is that greater than 1? No. So this right here would be considered decay. And guys, when you are decaying, you are always decreasing, right? So we are decreasing. So guys, I want you to think about a couple things right here. This 0.98, how far away from 1 is that? So guys, if we're doing this and we say 1 minus 0.98, that gives me 0.02. So guys, what percent decay is that? That is, because we move this right here, we move it over, and so guys, this is 2% of a decrease. I also like to, so you can either turn it into a percentage after you've subtracted, or you can think about it like this. 0.98 is 98%. How far away from 100 is that? 2%. So it's a 2% decrease. All right, guys? So this 0.98 is like 98%, and so it is a 2% decrease. Does that track? Yes, no, maybe so? Okay. Let's look at this guy here. Okay, now guys, did the 15 control anything with our growth and decay? No, that's just the A value. All right, guys? We're not worried about that right now. Okay, now let's look at this guy. Romina is 1.75. Is that going to be growth or decay? Growth. So that growth right here is also going to be an increase, right? When we grow, we are increasing. But how much are we increasing by? So 1.75. So guys, when you do decay, you subtract it from 1. When you have growth, you subtract 1 from it. Does that make sense, guys? So 1.75 minus 1, and guys, that is going to give me 0.75 So if we move that over, that becomes a 75% growth. Okay? Or you can think of it and say, oh, that's like 175%. So that's a 75% growth. Which way is better for y'all? To convert it first or to convert it second? Does it matter? You move the decimals, All right, so let's look at this guy right here. Okay? Negative 2,000 times 0.75 to the x power. So, Emerson, would this be growth or decay, sir? This would be decay because it's smaller than 1. And if it's decay, it's going to be a decrease, right? So that decay means it's decreasing. So you can either think about it like this, where you're saying, okay, that's 75%, right? So you could move it first and say 75. You can move those decimals first. 100 minus 75 is 25%. Does that make sense? Yes, ma'am. Okay, hold on just a second. We're going to get through our notes here, and then, so if it's not an emergency, I want you to stay put. All right, so you guys feel pretty good about that? Yes, no, maybe so? So that becomes our 75%. So you can either move it before or you can move it after, but either way, it's a 25% decrease. All right, 1,000 times 0.57 to the x power. So Nico, is that growth or decay? Decay. And so how much is it decreasing by? 43%. So if we say 1 minus 0.57, that gives me a 0.43 or a 43%. Does that make sense, guys? Are you guys tracking that? I will tell you guys this right now. This is one thing that I almost use definitely weekly. I don't want to say daily. But guys, because here's the deal. When I'm calculating how much it costs for certain groceries, do y'all know the tax rate when you guys buy stuff at the store or when you guys go anything? Do you guys know the tax rate? 8.25%. So guys, if you ever want to know how much something is going to cost that actually has taxes, this is what I do almost any time I'm trying to figure out how much something costs. So guys, if something is $9.99, if you multiply it by 1.0825, because it's 8.25%, right, above 100, my total cost, so guys, if you're buying something that's worth $9.99, and the tax rate is 8.25% of an increase, then guys, what I'm actually paying is $10.81 when you go to the register. Does that make sense? So you could also, if you wanted to do $9.99 times 0.0825 times the percentage, you can say, oh, it's 82 cents in taxes. $9.99 plus 82 gives me $10.81. I prefer to do it in one step and just multiply it by the 1.0825. Does that make sense? Guys, I'm the one who does our budget in my family. That shouldn't be a huge surprise. I'm a math teacher. But so guys, that is literally what I do all the time. I use this little formula here every single week when I do our budget, when I'm trying to figure out how much things cost and where they should go and which category they fit in. So guys, that right there, I'm multiplying it by that percentage amount, okay? So guys, if we are given a real situation and we want to find an equation, or we want to write our equation from this, we are going to take a look at this. And guys, so that A is still going to be that initial value. Instead of your y-intercept, it's your initial value. And guys, your B, or your growth or decay factor, sometimes they give it to you, sometimes they don't. And so guys, if they don't, you might have to figure it out. And so guys, how we find our growth or decay is we do that y2 divided by y1. Y'all did this actually last class when you guys were finding the B value from a table, right? You would do y2 over y1. Same thing is true in a real world situation. So guys, let's take a look at this one here. Researchers studied the population of a town over time and modeled the data using this exponential function. The initial population was 48,000. So guys, what value is 48,000 going to be? That's going to be our A, or our y-intercept, our very beginning. After the first year, the population of the town was 50,400. So guys, question, is my population growing or decaying? Growing. It's getting bigger, so it's growing. So that means this B value better be bigger than 1. Does that make sense? So if the population continues to grow at this rate, which function can be used to model the population? So guys, or write a function that can be used to model the population. So guys, what we could do is we could say 50,400 divided by that 48,000. I don't know what that is off the top of my head, so I'm going to use my little calculator here. 50,400 divided by 48,000. Guys, that gives me 1.05. So guys, that means that my B value, guys, you can write it as that weird fraction, or you can write it simplified, okay? So guys, my equation would be y equals 48,000, right, times 1.05 to the x power. And guys, you can also see it as y equals 48,000 times, I've seen it like this before as well, times 50,400 over 48,000. Guys, I think this one is way clunkier and a lot uglier, but you are welcome to write it that way. Okay, guys? I just want to show you where we're getting that 1.05 from. Does that make sense? So, guys, how much is it actually growing by? What is that rate of growth going to be? 0.05. So we say, okay, 1 minus, or we're saying 1.05 minus 1 gives me 0.05, or that is going to be 5%. Do you guys feel pretty good about that? Yes, no, maybe so? Guys, a lot of this is the biggest things is identifying what's my B value, what's my A value. Those are the two main things that we got to worry about. Okay? So now we're going to flip to page 5. I don't know. Sorry, it's all wonky. All right. So we're going to talk about this guy. Ooh, so this time they gave us the equation. This function, W of t, can be used to estimate the number of whales in the North Atlantic Ocean at the end of t years. So it's W of t is equal to 270 times 0.975 to the t power. Identify all the key attributes. So guys, what's happened to my whales? Is their population increasing or decreasing? Aw, poor whales. All right, guys. So let's look at this. What is my A value in this case? 270. And what does that actually represent? Yeah, there's 270 whales at the start. All right? Or when we started measuring, when we started counting, our initial number of whales was 270. Okay? The B value here is this 0.975. Guys, what does this represent? Yeah, it's the decay factor. All right, guys? So it's basically what you are multiplying that 270 by each year. Okay? So after 1 year, you just multiply it once. After 2 years, you multiply it twice. 3 years, you multiply it 3 times. So guys, the rate of decay, we would look here and we'd say, okay, 1 minus 0.975. And guys, what does that give us? Yeah, 0.025, which is just 2.5%. So it is a decay of 2.5%. And then, guys, oftentimes what happens is they say, okay, in 5 years, what would be the population of your whales? So, guys, if that was a question, then what you would say is you would say, okay, 270 times 0.975 to the 5th power. Because we would want to know if that's not what's being asked right here. But, guys, there would be times where they'd say, okay, use that equation to find the population after 5 years. So we'd probably want to round it. So that's what, 237.89. Oh, so after 5 years, there would be 238 whales. Oh, because they keep decreasing at a rate of 2.5% a year. Does that make sense? Yes, no, maybe so? Okay. So now, guys, let's take a look at this guy. A bank account earning annual compound interest. Guys, if you are earning interest, should your money be increasing or decreasing? Yeah, if you are earning annual, that means earning yearly interest, that should be growth. Does that make sense? Because you're earning interest. Okay, and no additional deposits or withdrawals were made after the initial deposit. The balance after X years can be modeled. Oh, they actually gave us the equation. E of X is equal to 850 times 1.025. Identify all the attributes. So guys, what is my A value in this question right here, Conrad? Conrad, what's going to be my A value? 850. And what does that represent, sir?
Number of years.
Okay, so it's not our number of years. So the number of years is going to be your X, okay? The X years. Do they say the X years right there? So what does that 850 represent, Tanner? Can you help them out?
Would that be your money in your account?
Yeah, so it's the initial deposit, right? It's the initial deposit or the initial amount of money in your account. So that means at the beginning, they deposited 850 bucks. And then they just put it in the account and they let it sit there and they let it grow with interest over the years. Now guys, what is my B value in this case? Let's go for it. Bella, what's my B? 1.025. And what does that tell us? It is a growth factor. It is how much my money is growing by this time. And guys, what is that rate of growth? Well, we take that 1.025 and we subtract 1, which gives us, again, 0.025, which is just 2.5%. So guys, up here, our sweet little whales were decreasing by 2.5%. Now our money is growing by 2.5%. Okay? And I want you to take a look at this. They're both, the rate of decay was 2.5%. The rate of growth was 2.5%. But guys, my B value up here was 0.97. Here it was 1.025. Do y'all see how that works? That's 2.5% below and then 2.5% above. All right, let's talk about this one here. This year, the number of students who participated in sports was 317. Each year, the number of students who participate in sports decreases. Oh my goodness. So guys, it is decreasing. So should it be growth or decay? Decay. Should be decay. And guys, it's decreasing by 4%. So guys, 4% can be translated to 0.04 in decimal form, right? You move your decimal point. So which one can be used to model the number of sports participating, or the number of students participating after X years? So guys, what does that 317 represent? That's our A value. So guys, are there any that you can look at and say that we should just throw out right away? That's not a good one. B. B is a linear equation. When you're increasing and decreasing by a percentage, that's going to be exponential. So B is linear, so that's no good. Now guys, are there any other ones that you feel like you could just throw out as trash? Yes, go for it, Cheyenne.
C, because the X is greater than.
Yeah, because this right here, that is growth. We want decay. Does that make sense, guys? So it's a lot of this is going to be like common sense kind of stuff. You look at this one, that one's linear, so we don't want it. This one is growth, so we don't want it. We're only going to look at our two decay ones right here. And you notice we have our 317 and our 317. So guys, which one has a, it's decreasing by 4%. So which one has the correct decay factor, Emery? D. Why is it D? You are correct.
When you subtract it from 1,
yes.
0.04, which when you round it is 4.
Yeah, so when you subtract it from 1, it gives you that growth or that decay factor of that 0.96. Do you guys see how it would be easy to get tricked by a problem like A? But guys, that's not a 4% decrease. That's a 96% decrease. Does that make sense? Because it's going down 96% to get to that 0.4. Y'all tracking? Yeah. That's a big decrease. But y'all see how that would be, you would be easy to miss that one. All right, let's talk about this guy. An insect population after X months can be modeled by this. Identify G of X is equal to 18 times 1.3 to the x power. And it says identify all key attributes of the given function. So guys, my a value again, Baron, what's my a?
Your A would be 18.
Perfect. And what does that 18 represent? Okay, it's our y-intercept. But what does it represent in this specific situation? You are right. I'm going to put our y-intercept right here.
The population at the start.
Yeah, it's the starting population of our insects. So our insects start at a population of 18. I don't know if that's like 18,000, 18 million, but it starts at a population of 18. Y'all good with that? Okay. And then, guys, it says what does A, so that's the A, so that's our A represent. And then, guys, let's look over here. Miss Luna, what is the 1.3 right here? We have our 18 and we have our 1.3. That's our B value. And what does that represent? Okay, growth, so it's our growth factor. So, guys, as normal, especially in the state of Texas, our insect population is growing. Right? I feel like the mosquitoes are so bad right now.
No, but didn't they try to die yesterday?
I hope so. Man, I hope so. We'll see. We'll see if they bounce back. I hope they're not very resilient. All right, so guys, I feel like they waited a long time to show up this summer, and then when they came, it was so bad. But yeah. All right. So guys, what is it? So we know that it's growth. So guys, what is the rate of growth?
30%.
30%. So guys, 1.3 minus 1 gives us that 0.3, or in our case, 30%. So it is a 30% growth. Do y'all feel good about that? Yes, no, maybe so? Okay, cool. All right, so now guys, we're going to talk, we're going to do a couple more. We have 4 more we're going to do, and then you guys do homework. So guys, this time, I want you guys, now you're going to be given the rate, and now you have to write the equation, okay? Before I gave you the equation and you had to figure out the rate. Now we're going to be given the rate and we have to write the equation. So guys, you purchased a car for $17,000, okay? The value of the car decreases about 2.5% each year. Write an exponential function to model this situation. So guys, what is my rate of growth and decay here?
2.5.
It's 2.5%. So guys, they gave us that 2.5%, and we know that it is decay. So guys, yes ma'am?
Oh, but it's greater than what?
Okay,
Oh, that's the percentage.
it's giving us the percentage. So last time, Romina, I was giving y'all the actual factor. This time I'm just giving you the rate. Does that make sense?
So I don't really get it. So when it's over, so let's say 2.5%, do you subtract that from 1, or do you subtract 1 from 2?
All right. So if you are given the factor, then you subtract it from the 1, right? But let's look at this. So we have this. We see that 2.5%. We can turn that into 0.025. Are y'all comfortable with that? And then we know that our A value, our starting amount, how much it was worth at the beginning, was $17,000. Now, this is a good conversation. Emery is saying, do we subtract 1 from the rate, or do we subtract that rate from 1? What do you guys think, Baron? Okay, well, so reading the equation.
Oh, it says decrease.
There you go, there you go. So because that's decay, no, you're good. Because it's decreasing, we see the decay. So you have to read it. You have to read it. No, you're good. Because if it just said it's something 2.5%, you have to look for the key words that do growth or decay. Okay? So that one's decay. So guys, what should we do to get our B value? First of all, is my B value going to be greater than 1 or less than 1? So if it's going to be less than 1, then we should say 1 minus 0.025. And if we do 1 minus 0.025, does that make sense? It's going to be 90.975. If you subtracted 0.25, that would give you 75%, but that's a 25% decrease. We only have a 2.5% decrease. So guys, if we have our A and we have our B, can we write our equation? Y equals 17,000 times 0.975 to the x power. And then, guys, it says find the value of the car after 4 years. So, guys, what do we do with this? Yeah, go for it, Sarah.
Do we plug it into the x?
Yeah, we make x is equal to 4 now. So now we do the exact same equation. We say y equals 17,000 times 0.975, but we raise it to the 4th power. And so, guys, this is where you're going to need your calculator, okay? I mean, I guess technically you could do this, but it would just take a super long time. So 0.975 raised to the 4th power. And so, guys, after 4 years, this guy's car, how do you do that? Do y'all know how to do that? Type in the exponent like that? You do the little caret button, pushes it up, boop, all right, to the top there. So that gives us 15,362, and then I'm going to say, and 69 cents. Does that make sense? So after 4 years, my car is worth $15,362.69.
What equals are just like
You can write y equals. Sorry, I didn't write that out to the side. So the cost or the value of the car is $15,362.69. Do y'all feel good about that? Awesome. All right, so let's look at this guy right here. Tim, our guy Tim. Ugh, I had a boyfriend named Tim. Yeah, that's cool. He wasn't the one. All right, so here we go. So, he wasn't. So, here we go. So, Tim opens a bank account. It's cool. He's married. He's got kids now. We're good. We're friends. So here, Tim opens a bank account with $100. All right.
Why'd you seem so disgusted? Were you guys are friends?
Well,
He cheated on you?
we don't need to talk about it. I'm being recorded right now, Nico. Here we go. All right. So here we go. He earns an interest. We'll talk about it in a second. He earns an interest at an annual rate of 6%. Okay. So if he's earning interest, guys, is this growth or decay? Growth. So that's how we know. We have to look here. So this is a rate of growth. So, guys, my rate of growth is that 6%. If we want to turn it into a decimal, it's 0.06. All right? So 0.06. Okay, guys? And then we earn, so it's about $100. All right? And so he starts with $100. And, guys, so what is my B value going to be here? We are going to say 1 plus 0.06 to give us that 1.06 because he's earning that. It's growth. So if we write our equation, we say y equals 100. That's our initial amount times 1.06 raised up to the x power. And how much money will be in his account in 144 months?
A year.
12
years.
Ooh, okay, so guys. Okay, so quick question though. Quick question, guys. If it's an annual rate, is that monthly or yearly?
Yearly.
Yearly. So guys, we're talking a yearly rate. So, do we plug in 144 for x?
12.
We plug in 12. So guys, our x is going to be 144 divided by 12. So guys, it is 12 years. So when we plug that in, we say y equals 100 times 1.06 raised to the 12th power. So guys, if Tim opened a bank account and he put $100 in the bank account and then he just left it there and he didn't touch it for 12 years, all right, he didn't put any more money in, he didn't do anything to it, it would double. It would get all the way to $201.22. Now, you might think to yourself, that doesn't feel like a lot of money. But, guys, that's doing nothing. All right? That's just putting it in the bank and letting it sit there. So it took 12 years for it to double, which is kind of a long time. Okay, guys? So that's the thing about earning interest in financial places, guys. If you deposit money and then you never deposit any other money again, it's not going to work as hard for you. But if you deposit money slowly and you do it monthly and you do it consistently, then your money continues to grow. Okay? So after 12 years, now they got $201.22 in the bank account. Y'all good with that? Okay. Now we're going to look at this guy. This one's a little different. Tennis tournament began with 128 players. So guys, what's the 128?
A.
That's all right. A, that's where we start. Each round, half the players are eliminated.
50%.
Ah, look at you. So guys, that means our rate of growth and decay is 50%. So what is my B value then?
0.5. Isn't it?
It's just 0.5.
That's the same thing.
Oh, what'd you say?
0.5.
I think you said 2.5. Okay, there we go. 0.5. Yeah. So guys, when a lot of times, so in biology and stuff, they talk about half-life. And so guys, when something decreases by half, like there's substances like carbon and things like that, it has a certain half-life. So guys, that's where you do that 0.5. So my equation is y equals 128 times 0.5 raised up to the x power. Then guys, it says how many players are left after 5 rounds. So guys, you're starting with 128 players, and after only 5 rounds of playing here, so my x is equal to 5.
5 out.
Yeah,
4 players.
we only got 4 players left. So guys, it took 5 rounds to get from 128 all the way to 4. Yeah, so there we go. So guys, so that would give us, so guys, there are 4 players remaining after 5 rounds. Do y'all feel good about that?
Yes.
All right, now let's talk about the zombie apocalypse. Okay? So, zombie apocalypse begins with 2 infected individuals, all right? So, I don't know, maybe they're married, whatever. But here we go. So, we got 2 little infected zombies, okay? But those zombies, the zombies triple every day. So guys, 2 is my, y'all feel good about that? 2 is our starting amount. But guys, if it triples, that's going to be growth. Right, y'all? Sorry. So if it triples, what's my B value going to be, y'all?
Well, would it be 1.3 be repeating?
No, that would be decay.
Oh. 3?
It's just 3.
Oh.
It's just 3.
It's not 3.
Guys, if you triple, you're multiplying times 3, right? Every single day. So guys, if you're tripling, you're multiplying it by 3. So here's a weird question. So if we wrote our equation, it would be y equals 2 times 3 to the x power. So guys, what is my actual rate of growth here?
3%. No.
0.2%.
Hold on, 3, that's like 300%. So guys, so 3 minus 1, guys, that is going to be a 200% growth. Does that make sense? Because guys, think about it. So this is where things get a little tricky when people are talking about growth, like financial growth and things like this, guys. If you're tripling your money or tripling your number of individuals, that's a 200% growth. Because if you're going from 1 to 3, well, you only grew by 200%. Does that make sense? So 100% growth is really doubling your money. It sounds weird. I feel like people get really confused with that. So guys, you have to think, this right here, you scoot over, that's going to be 200% right here. So guys, then, question, it says, how many zombies are going to be there in 2 weeks?
956.
Wait,
wouldn't you take the days instead of, like...
2 weeks are how many days? There we go. So guys, we want to do 14 days. And so, guys, after 2 weeks, if nobody's killing off any zombies, guys, which is unlikely,
You can't
That is 9,565,938 zombies.
Well, that's like almost all of Texas.
I mean, not even all of Houston, but yeah.
If I were healthy, I'd
So guys, so guys, that's crazy. And this is why, guys, this is why exponential functions are really important. Because guys, you notice it's growing incredibly fast. So guys, when you hear people say, oh, that grows exponentially, that means it grows really, 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 really quickly. Does that track?
Yes.
Or if it decays exponentially, we have there. So, anyways, I hope that you guys have a wonderful, anyway, so what you guys can do now is go ahead, grab a Chromebook, we can get ready, and we're good to go.